start by that.
Okay, well, this is the design we've been working on. This is what we got so far. It's a Core XY design. We used most of the parts came from the parts list, at least not the exact links, but the same types of parts. We got linear rails. All these components here we're trying to get manufactured out of sheet metal, and that's some stuff that you guys can try and do as well if you want. We're still contacting manufacturers to see if they're going to be able to, but they probably will.
Not the bed. The bottom piece is that's just a
Oh yeah.
placeholder. It's that one's not gonna be cut out of sheet metal. We're gonna use a heated bed. We're just gonna buy it.
Yeah.
And you can see like we're using sheet metal and there are bends in it. So we're actually gonna get the
Mhm.
manufacturer to make those bends using like a giant industrial bending machine.
Yeah, there's a way in SolidWorks to like use the sheet metal features. I guess I could show that real quick. Just have to open this.
Yeah.
This is one of the sheet metal parts. And then all you do is you start out with a sketch, which is this is just a normal sketch of whatever the piece is going to be. And then you can come, you have to right click here, find the sheet metal thing wherever that is. It's in this long list of stuff. It's right here. You click that, and then it'll give you this menu. You click make a flange, and instead of an extrude, it just turns this into sheet metal. So you get the flat piece, and then you can come in and make bends. And then you can bend it like basically like paper and get whatever shape you want.
Yeah, we haven't decided whether or not we're gonna use aluminum or steel, but it's probably gonna be aluminum.
It's just gonna be whatever's cheaper, really.
Yeah. Aluminum is actually, it can be pretty strong.
Yeah.
And this isn't something you have to do. It's something we chose to do, just because we thought it would be a better design.
Yeah, it's easier in our opinion than just putting everything together manually. You already have holes in most of the parts. Everything is already where it's supposed to be when you put it together.
Yeah. And you see that model for the extruder that we found? We just grabbed that off GrabCAD. Same with a lot of these models, like the linear
Yeah.
rails and the NEMA 17 motors. You can just grab those off GrabCAD, just search them up, like the name of what part you're looking for, and you can just download the model and just import it into your assembly file. So you don't
It
have to
saves a lot
sit.
of time on
Yeah,
designing every single piece. I wouldn't have wanted to design this entire thing because it would have taken forever. But I just downloaded someone else's and put it in. Just made sure it was the right dimensions.
yeah, you definitely have to double check their dimensions and just like if it like looks right, it's probably right, but make sure to double check.
Yeah, there's been many times where we download something and it ends up not being what it advertised itself to be.
Yeah. And the if your computer isn't like super strong, like Matthew's gaming PC fueled with Dell Delphine gaming water,
Oh
you
yeah.
know, um, it might be hard to import a lot of parts that have a lot of like discrete parts inside of them. So, it might make sense for you to design your own thing if your computer can't handle like loading up a giant assembly file with a bunch of parts.
Yeah. Because this thing right here is a whole assembly in and of itself, just imported into this assembly. So there's a ton of parts in here. A lot of the time when I try and move things, it's not showing it right now, but it simplifies these into just polygons so that I could load them all quickly.
Mhm. Er, Um, we still haven't added like the Z mounting system and elevation system, but we're still
Yeah.
working on it. We only started like a couple days on the assembly file. Like we started this weekend on the assembly file. Let me show our part list.
Oh, you want me to stop screen sharing?
Yeah, let me screen share. All right, can you guys see my screen?
Yeah.
All right, well, this is our parts list. Basically, this is how I organized it. This link is just like I haven't decided whether or not it's a good part yet before I add it to our like before I finalize it. That's why I haven't like named it, but everything else is pretty much set. We found a link for aluminum extrusions. and we found a link for a bunch of different stuff. And this is our total cost for all four print. We have a team of four, so we sized everything up, the quantity we need by to
Multiplied by
like
4.
yeah, because like for example, like the BL Touch system, that's just the it's an auto leveling sensor that you would attach to your printer so it can auto level, and you wouldn't have to manually level it too much. It would just do it through mesh leveling. And we only need four of those because we need one per each printer. And so total cost divided by four is this number. I just I have this all like it's just all calculated in Excel. Like even these are just this row times this. This
No
I mean this
dysfunctions.
yeah, they're all just functions, and it just makes it a lot easier. Yeah. And I was thinking about adding acrylic sheets, but it's pretty expensive. I've been looking for a good supplier, and you know, it's like it's pretty expensive. It's like an extra $200 or $150 per printer if you want to have acrylic on every face. Depending on your size and
Yeah.
your supplier and shipping cost, it's pretty expensive. This is basically what we've got so far. And if you does anyone want me to share this parts list with them that so they can view it, just so like they would have like see what we're doing?
We could just put it in the Google Drive. I mean, there's no reason not to.
I know. Uh, like just something to be look out for is what like with 3D printers you need cooling fans for the filament in a few places. You here, let me show you. Sure. So here's a good example. Okay, so here's an extruder of a 3D printer, just like a random extruder. It has a cooling fan right here on the heatsink that is next to the stepper motor, just so like when you're pushing the filament through with the gear, like in this area where the filament goes in right here. You don't want this part getting too hot because then the filament would sort of deform when you're trying to push it, and it wouldn't be like a hard plastic when you're trying to push it with the gear. It would sort of melt. So that's why you have a cooling fan up here in the heat sink to dissipate all the heat from the hot end. So you'd want a fan up at this part, which looks like this. But you also need another fan if you want to do bridging when you're printing something. And that goes and cools the plastic coming out of the hot end. Like after it comes out and it becomes liquid in here. After it comes out, you want it to solidify really quickly after it's been printed. That's why you want a cooling fan with like a sort of this is actually a 3D printed piece. If you look closely, this black part right here, it connects to the fan. The air flows through and it goes around and it like shoots down towards the plastic that was just extruded and came out of the nozzle, and that hardens it really quickly. So I'll make sure you want a couple cooling fans. But the main point of this that I was like wanted to bring up is that you need to size your power supply voltage to the voltage of your cooling fans, depending on the control board you're using. Like we want like these cool LED fans, and I made sure that they were 24 volt because we want to use a 24-volt power supply.
Same thing with the extruder and the bed. You need to make sure the voltage is all the same.
Yeah. If you had like a 24-volt bed but then a 12-volt power supply, you would it would not heat up. It would just get warm. It wouldn't heat up. Has anyone ever like has anyone yet picked out some parts or like does anyone have a parts list I can look at so I can talk to you about like what you've chosen so far? Like motor driver wise, like there's a lot of elements to a 3D printer. And
Yeah,
I'm
or if you
sure
guys just want help like getting your parts list started or something, we're kind of just curious how you guys are getting along with this.
Yeah, like progress wise. Okay. This is this I think this is our recommended control board that we recommended to you guys. It's pretty good. MKS board. Let's just go to images. So looking for a specific image. I think this one will probably do. Nah. Because I want to explain to you like what exactly you need. Okay, this one. So this is the control board and this is what it looks like. This is where you plug in your power supply. And let me show you our power supply. Like this is our power supply. So basically what this thing is you plug in, this plugs into the wall. You get a wall outlet and you run the wires in and you screw them down in this orange casing right there, like right underneath the orange casing, those are screws. You just screw down the wires and then the output of this should be 24 volts. Because and it also has an adjustable knob, but you want it to be 24 volts, so you wouldn't touch that. And it's able to output at a maximum of 25 amps. And you don't really want to size up your power supply to be running at like its maximum power because it puts a lot of strain on the components. So you'd want to like give yourself some leeway. Oh, it's currently unavailable. I guess we're gonna have to find a new one. This one is just it just sold out. Maybe by the time we order parts, it'll be back, but we might need to buy a new one or find a new one. That's fine. That happens a lot. You know, a lot of these parts they only have like 5 in stock, and so if we run into that issue, we're gonna talk to you after you guys send us your parts list, and we'll try to find a replacement link for it or somewhere else so that we can buy it. Because that happens a lot, where you like you put it on your parts list and then you try to buy it like a month later and you can't because they aren't selling it anymore. They sold out or there's some delay. So there's a lot to look into. But this is what the control board basically looks like. You have these are where the stepper motor drivers plug in. Do you guys know what stepper motor drivers are from your research? Okay.
It's fine if you don't. It's a pretty simple thing to find out.
I'll explain it if you don't. That's punishment for
Oh,
not
wow.
answering. Yeah. So there's a few different options for stepper motor drivers. If we go to our recommended parts list. No. Recommended parts list. We recommended 3 different options, or we gave you 3 different choices. There's the classic A4988. Those are the cheapest ones. Then you can go for the DRV 8825. Those are pretty good. They're not bad. And then there's the TMC 22 08. This
Premium
one's
version.
yeah, this one will give you probably your it's the most expensive one, but it's definitely worth it if you guys can budget it. Because you would need to buy depending on your printer, probably most of you are probably going to be using 5 stepper motors, 2 Z's and then X, Y, so that's 4, and then you need your extruder, so that's a total of 5. And this comes in a pack of 5 for $20 or $19. So how these basically work is, let me find the link for that. So this is, for example, the DRV 8825. basically, these are the pins on it. It has the enable pin, the M0, M1, M2, reset, sleep, step, direction, V motor. So this is the voltage of the motor, and then this is ground. This is a decoupling capacitor, but that's already on your board. If you look at the MKS board, if you buy the MKS board, this is the decoupling capacitor. They already have that built in, so you don't have to worry about that. And you have the different pinouts that go to the motor and ground. Okay, so the board takes care of a lot of things for you, but you do have to define your step size and using these pin headers right here. If you use this board, basically you put a jumper here, and depending on where you put the jumper, it would define the step size. Depending on your stepper motor driver, you'd have to look up the specific stepper motor driver different inputs to get the different step sizes. But for this one, for example, if you have 3 jumpers on, it will do its minimum step size of 1 32nd step per signal. So every time this step pin right here gets a signal of a 1, it will move the motor by 1 step. But because these stepper motor drivers are really cool, they're able to do micro stepping. So every time it gets a signal from this microcontroller of a 1, it will move. Let's say if all the pins are high, it will move. If you have all 3 jumpers on, it will move 1 32nd of a step. So that means it will give you higher accuracy in your movements because you can control more accurately how much it moves. And when I say step, I'm sorry, let me backtrack a little bit. When I say step, every time, because we're using the NEMA 17 from our recommended parts list, and the NEMA 17 has a resolution of 200 steps per revolution. So that means every time it gets a signal for a step and it takes a full step, that would be a 1.8 degree movement of its rotor. It would just rotate 1.8 degrees. And that's just the full step degree of accuracy. Every time you send it a signal, it will rotate 1.8 degrees. But because you're able to do micro stepping with these stepper motor drivers, it allows you to do 1/32 of 1.8 degree movements for each step. Is this making sense to you guys?
You're doing a good job, Jason.
Thank you, Matthew. Thank you. Anyways, this is important for you because when you're writing the program for Marlin to control your 3D printer, you need to tell it what step size you configured it to be, which how you set up your jumpers, and what step size you're using, because it needs to know how often it needs to send the step signal to your device in order to move, like, let's say 10 millimeters. If you want to move the X motor 10 millimeters, you would have to send the step signal a lot of times. But if you want to move it 1/32, and it's like in the full step mode, you have to send it a lot of times, because depending on the rotation or like the size gear you're using on the motor, you know, the rotation is going to be different. The amount the belt travels to move 10 millimeters. I think I lost you. But here's an example. I guess they have a video. I don't know. A lot of this, I haven't looked at this video, but you know, it's not worth it. But you have to tell it what step size you're using is what I'm driving at, because it needs to know how often it needs to send the signal to the stepper motor driver in order to move move in the movement that it that you want.
Yeah. So basically, these are just components that you plug into the other board,
Yeah,
and the way you plug it in kind of tells it what step size it's going to have. And then whatever step size you choose, you need to go into the firmware that you download and tell it which one you chose.
Yeah, and that's in Marlin. You would have to open up the it's not like programming, but it's just like modifying a program.
Yeah.
So you aren't having to write a function, you're just having to define values in Marlin. to make sure that your printer works the way you want it to. And this is where your stepper motors plug in. This control board actually supports 2 different extruder motors. But if you want to have 2 Z motors, it only has 1 outlet. So you'd have to figure out a way how to wire both Z motors through 1 outlet. You can wire them in parallel, and they will have the same movements as if they were on different stepper motor drivers. They will, like, if you wire them in parallel with each other, the wires, they will
They'll just move like they're the same motor.
yeah. They'll move the same distance. And this is where the heating element plugs in. Your hot end for your nozzle or your extruder, it plugs in there. And then this is where your heated bed plugs in. And also, a lot of the time you want an LCD. Like, I think the, what's it called? The 128 LCD, something like that.
Well, you can just look up any LCD screen. It's not too important for now.
Yeah, but the ones that the most common one is LCD, because it just plugs in so easily into this board. Shopping. Here it is.
Oh, there it is.
It's the 12864. It plugs in super easily because it has the connectors for it. And you just plug in the back, and then Marlin, you can configure it. You need to tell it what LCD you chose, and you can just plug it in, and it should work. It also has an SD card slot, like not a micro SD, a normal size SD card slot, so you can upload your files that you to print. So that's where you would upload the files to be printed. You don't have to have it like hardwired connected to your computer. You can just download the files onto an SD card and then just stick it into the 3D printer right here on the slot. Has anyone started on an assembly file or any SolidWorks parts yet?
I have like a frame built.
Okay. Did you use aluminum extrusions?
Yeah.
Okay. I'm just curious. Are you using like extrusion shopping? Do you plan on using brackets that look like this?
Something like that, yeah.
Yeah, you just gotta be careful with these because they can get loose over time. Like, if you tighten these screws and you think like this joint is secured and it's not gonna move, it might not, but it really depends on where it is. And if you just have it like for this one, for example, it has it kind of secured right there, so it probably won't move. But they can loosen, the screws can loosen, and it can slide a little bit, which isn't great.
Over time, just like from the extruder and everything moving and vibrating around, it'll just like loosen the screws.
Yeah.
So you could just put some like Loctite in there or something if you want. It should keep it tighter for longer, but that's just something to look out for if you're using those.
Mm-hmm.
We also plan to use like plate brackets that would mount on like the side of that.
Oh yeah, I saw those. Those would have the same problem really, but it's like they both should work fine if you just like put something in to make sure they don't rattle loose over time.
Yeah, something like that.
Yeah. I've been in contact with a few manufacturers to see if they can modify aluminum extrusions and drill holes exactly where we want them to be. So I'm gonna try to get someone who's able to do that for us, and I'm probably gonna be able to find someone. So I wouldn't be too afraid of just like modifying an aluminum extrusion by adding a hole in it and keeping that in mind. Or like you can do that in your design. I'll let you know in like a week or two of like how certain that is, but I'm pretty sure like this week I'm looking for manufacturers to build everything and like have like machine shops, and they can just CNC the parts that we send them and give it back to us.
What if we wanted to like cut an exchange to like a specific length?
Yeah, that shouldn't be too big of a problem for them to do.
Okay.
Yeah, because a lot of the time they sell them like in millimeters, and they go like 450 millimeters to like 500 millimeters, not really anything in between. Yeah. Have you looked at an extruder yet for your printer?
Like the hot end of it, or
Yeah, like the hot end and like the gear system or whatever.
I think we were gonna go with what my team was planning on doing was just going with the ones you guys recommended.
Yeah, okay.
Yeah, it's a pretty decent one.
I've seen a lot of good reviews for it. I haven't actually used it before, but I've seen a lot of good reviews. Yeah, that's a big thing of it. Just like looking at videos. A lot of the time, like for anything on the parts list, you can find a video for it. Like the BL Touch system, here's a video I found of someone using the MKS board, and they added the BL Touch system. All right, dude. Okay, dude. He tells you how to set it up, and then he'll probably show you at the end it working, which I guess he didn't. He just decided not to.
Yeah.
Oh, he just shows you it like
Receiving a
just-
signal.
yeah. So this is basically how it works. Oh, this is a 7-minute video.
Yeah.
Okay, I'm just gonna. Oh my goodness gracious. All right, so what it'll basically do it will automatically go to the different you can set it up to work like this. It would go to the different corners of your build plate and then send out that button, and it will know what distance it traveled, and it will just know exactly where the build plate is at that corner, and then it's able to figure out how it needs to compensate for the bed not being perfectly level while it's printing.
So basically, you just don't have to do it manually. It's just kind of a quality of life thing. Your printer will just do it for you.
Yeah, it'll make it a lot easier for you if you choose to add it. I mean,
You don't have to. It's not necessary by any means.
if you're using the MKS board, it's pretty easy to set it up. Yeah, I don't know. There was a few electrical engineering people or compy majors, and if you're interested in learning more about like the circuits and the components on the circuit and how that all works, just send me a message, because I don't want to like bore everyone with that, because a lot of people, they just don't care. But I'd be happy to like sit down with you and explain to you how everything on this board works, because that's what I do for fun. Yeah, a lot of the stuff, the MKS board isn't actually open source, where they haven't released their files for it because they sell it. But the board that this board is based off of, the Ramps board, that one is open source, and all the board files were released.
Yeah, but we don't really recommend using that board. It's kind of a
Yeah, I would not recommend using the Ramps board because it's got some very bad flaws, where like this green connector on it isn't like rated for high voltages, so it can melt a little bit and it won't smell good. Also, these fuses right here can also burn out for no reason, and they're just annoying to replace. You can replace them pretty easy. They're just a little bit annoying. These MOSFETs are like, they have a tendency to overheat, especially the bed one, because it's not a very big MOSFET. It can work at the voltage, but it's like it heats up a lot and it just takes a lot of power right there, and it gets really hot, and that's not good for electrical components really most of the time. So I wouldn't recommend using this board. It will work. It's just not the best.
You'll probably see a lot about it when you're like looking at different boards and stuff. That's kind of why we bring it up.
Yeah, just know if it
Very
works on the
popular.
Ramps board, it can probably work on the MKS board. The only good thing about the Ramps board is that it gives you 2 slots for the Z motors. It gives you like so you can plug in directly 2 different Z motors and you won't have an issue. But the MKS board for some reason decided not to do that. They have different versions of the MKS board that probably do have that. But most of the ones that you can find are a little bit outdated and they don't have 2 Z slots. They only have 1 Z slot. So you can only plug in 1 Z motor. It's a little bit annoying because usually 3D printers have dual Z.
I mean, if you're designing your printer to only have one Z motor, that's obviously not a problem, but
Yeah, it's kind of hard to design your printer with 1 Z motor, especially if you want like a big volume, big print volume.
yeah.
I recommend you use 2 Zs, but yeah, that's just me. Hey Vincent, since you're the most active person, what printer are you basing yours off of, if you are?
We're doing like a Cartesian. I mean, not a Cartesian. Core XY design.
Oh,
Are you
that's
basing
like
it off
one
of
of
any printer particularly, or just Core XY 3D printer and then?
Like, I mean, there's like a few images, but I don't know what exact printer it is. And I'm taking like bits and pieces from like personal builds and kind of
Yeah.
seeing like if there's like certain components I like and want to incorporate it into mine. That's kind of how I'm going about it.
Okay.
Yeah, that's actually a good way to do it. There's a lot of custom Core XY printers. Like if you look up Core XY, most of them are just like custom printers that someone built. And they use 3D printed parts for it. And this guy has a wooden build plate.
That's pretty funny actually.
I was looking at this guy. I want to see his printer.
Does he print in this video?
I hope so.
Doesn't look like it.
Wait. Oh, come on. He's got a print. Wait.
Surprised his extruder doesn't like partially melt.
Oh, because it's like plastic.
Yeah, I mean the whole thing around it is just printed.
I mean, we made our printer, the big boy printer. It had
If you look at another angle though, like look how close it is to heat block. There's nothing.
No, that's the V6 right there, and this is
Oh.
the cooling fan. So like it
Maybe
attaches up here to the V6 like a Bowden drive, and then it just clamps on. No, that should be fine.
I mean, probably if he left it like that.
I mean, he does make his printer out of wood, so it's like, can we really trust?
I can't fault him for that one.
He uses glass, so that's fine.
Yeah.
But he also uses, that's weird. He didn't use a threaded rod for his Z. He used a belt.
I've seen that before. Yeah, I don't know why someone would do that. I mean, it's cheaper.
Yeah, it's definitely cheaper. It's just I don't know, I feel like that's a lot of strain to put on a belt.
I mean, his bed's probably not very heavy. It's just a piece of wood and a piece of glass.
You're right. It was all thought out.
But also, whatever he prints on there, if he prints something big, it might get a lot heavier.
That's true. Yeah.
So far, I mean, we're also doing a Core XY design. So far, the hardest part has been just making sure we have room for the belt to go around everywhere.
Oh, show them the belt thing. Let me stop my screen share.
Oh, yeah. There's a way to route belts in a SolidWorks assembly file. I don't know if you know about it. I just learned about it. I don't know too much, but I could show you of its existence real quick.
Teach us.
Yeah. So if you want to try and route your belt around, because the belts in Core XY is kind of complicated, it might be easier just to see how it's going to move around your thing so you know it doesn't interfere with anything. you could, oh, I'll go back. You can click right here, go to the belt and chain thing. And then all you really got to do is click some like circular faces or edges. And then it'll automatically start like making a belt in between them. This one doesn't have a gear on it, obviously, so it's not going to be completely accurate as to what we actually want, but we have a belt here. You could make the belt go like around this way, and it'll help you like visualize where it's going to be and how it's going to connect to things. And you just click this, it just comes in as a sketch. There's probably a way to make it an actual part, but I haven't looked into it too much. I've just been messing with it a bit.
Yeah, but it's helpful just so you know that your belt clears where you think it will.
Yeah, like right here, it does not. So we'd have to move it like up or this down a little bit.
Oh, it doesn't clear? Oh, no.
Nah. But yeah, it helps out.
Yeah, now we know.
Well, I already do, but I just didn't fix it yet.
Okay. Ooh, we can also change those right angle metal brackets that attach to that middle aluminum extrusion, and we can have them hold our pulley system, our belt system.
This one, yeah, I was gonna make it a little
Well,
extension.
not that one, the other ones, because you need ball bearings.
Yeah, this hole right here was gonna hold the thing, but it has to be parallel to this. One of these belts has to be parallel. I don't remember which one, but whichever one is gonna be in this hole. As I
Alright.
move it. Yeah.
If we were to design our own part, would we only be limited to like sheet metal, or could we CNC something, like for example, or like mill something? Would that be too much?
I don't know. It really depends on, you have to design something keeping in mind that it's supposed to be fabricated to be milled, you know? Same thing with the sheet metal design. You have to design like feasible parts that are able to be constructed. Like I'm talking to like I need to reach out to more places in San Diego because I'm trying to go like a local machine shop to get everything machined. And I'm trying to find places that can do all that. And I know that they exist. And hopefully they fall within our budget.
Yeah. You
with
can
everything.
probably get something CNC'd, but we have to actually find a place that responds to us before we can say that for sure.
Yeah, we're not trying to say that to get these parts machined that comes out of your budget, because we have allocated some money just to getting parts machined beforehand. So we just need to make sure that everything falls within budget.
Okay.
Yeah, but I wouldn't say it's unreasonable for you to think that you can do that. Like it's probably it could probably happen.